Hello folks, so this is the second of our videos on the reverse chain rule, and just a reminder that many of us use this idea called GDA, or guess, differentiate, adjust, to do the reverse chain rule. In this video we are going to look at some slightly trickier functions. We're going to be integrating functions of functions with their derivative on the outside. So we might have a function f of x raised to a power multiplied by the derivative of that function f of x. So also we could have e to a function f of x, again multiplied by the derivative of that f of x. Perhaps not as easy to spot these ones, but with practice you will get the hang of looking out for when you can use GDA. So hopefully it will become a bit clearer with some examples. So let's look at some. This first one, we've got e to the power of 5x squared plus 8 multiplied by 20x. And important to note here that here is our inside function, 5x squared plus 8. When you differentiate that, you get 10x, I hope you'll agree. And out here we've got some multiple of 10x. In fact, we've got two lots of it. So we have indeed got the derivative of the inside function, or a multiple of the derivative outside. So we can use GDA. Our guess is just going to be the exponential part. So our guess is just e to the power of 5x squared plus 8. We then differentiate our guess using the chain rule. So e to the power of something differentiates to itself, but we also have to differentiate the inside function and bring that out to the front. So differentiate 5x squared plus 8, we get 10x, so our derivative will be 10x e to the 5x squared plus 8. We then compare our derivative to the original function, and in this case you can see that the derivative is 10 lots. The original function was 20 lots, so we need to multiply by 2, in which case we also multiply our guess by 2, so we end up with 2 lots of e to the 5x squared plus 8, and as usual we need to add our constant. So there's the first one. Second one, slightly trickier to spot. What we've got to note here is that we've got a sine cubed x, which really is just sine x all cubed. So here we've got a function sine of x raised to a power multiplied by cosine of x, which hopefully you recognise as the derivative of sine x. The constant at the front doesn't matter at all. Alright, so it's the same sort of style as the last question. Our guess is just going to be our sine x but raised to one higher power. So our guess is going to be sine to the 4x. And you'll see why that works when we differentiate it. If we differentiate this using the chain rule, then we differentiate sine x, which gives us cosine x, and we bring the 4 down to the front and drop it by 1. So we actually end up with the 4 coming down to the front, dropping the power by 1 and multiplying by the derivative. And hopefully you recognise that this function here is indeed very similar to our original. In fact, it's twice the size. So to get from our derivative to the original function, we need to halve, which means we also halve our guess. So our answer to the integral is going to be half of our guess, half of sine to the 4x, plus our constant. This next one, again, not easy to spot this one. Definitely not nice when we're working with integrating and differentiating and there are roots. Much better to write things in index form. So we've got to think, right, we've got something over the square root of x squared minus 3 here. Well, that's equivalent to multiplying it by that function to the power of negative a half. So just check that you're happy with how to get to this second form of the expression. Once you've got to this second form, hopefully it's a bit easier to spot, because we've got a function x squared minus 3 raised to a power. The derivative of this inside function is just 2x, and out the front we've got some multiple of the derivative. So again, we can use this GDA method. Our guess is going to be the inside function raised to one higher power. One higher than negative a half is positive a half. So our guess is going to be our inside function x squared minus 3 to the power of positive a half. We differentiate that using the chain rule. So the half comes down to the front and we drop the power by 1 to negative a half, but we also need to differentiate the inside function and take that out the front as well. So in fact out the front we're going to have a half, but also we're going to have 2x. Half lots of 2x out the front, which is just x. So when we use the chain rule to differentiate, we end up with this expression here. If you're not sure about that, then perhaps just go back, look at your differentiation using the chain rule, and make sure you can understand how to get from this function to this derivative here. Okay, compare this to the original function and you can see that our original function is 8 lots of our derivative. So to adjust our guess, we just need to multiply it by 8. So we can say that the integral of our original function is 8 lots of our guess plus the constant. One more here. We've got cosine of 10x cubed, and at this time out the front we've got a 5x squared. Well, if we differentiate the inside function 10x cubed, then we end up with 30x squared. So this is certainly a multiple of our derivative, so it looks like it's going to work out fine. Our guess this time, rather than cosine of the inside function, we will integrate, so our guess would be sine of that. So my guess is going to be sine of 10x cubed. I differentiate that using the chain rule, so sine is going to differentiate to cosine, but then I also need to differentiate the inside function and bring it out the front. So I end up with 30x squared into the cosine of 10x cubed. I can then compare that to the original function, and hopefully you can see that it's 6 times too big. I need to divide it by 6, so therefore I also need to divide my guess by 6, which is equivalent to multiplying by 1/6. So I get 1/6 of the guess plus the constant. I just wanted to show you how, in actual fact, the examples we did in the first video, this was one of the examples in the first video, are actually just doing exactly the same thing. Here we've got cosine of a linear function, but if we differentiate this inside function, we end up just with 3. So you can imagine that out here there would be a 1, which is kind of a multiple, it's a third of 3. So in actual fact we were using exactly the same method last time. It's just because all of our inside functions were linear, we didn't need to worry about the derivative on the outside, because constants we can just remove anyway. So in fact it's exactly the same. We would guess at the sine of this function, and then we differentiated that to get 3 cosine of 3x minus 2, and then we compared and said, right, we need to find a third of our guess, or so it's a third of sine of 3x minus 2 plus the constant. So that was just to show you that in fact this method is no different to the last, it's just a kind of next step up. Right, 3 questions here again for you to have a go at, so just pause the video, try the questions and then come back and see how you've got on. Okay, so first one, very similar to our original example, but this time 3x squared minus 7, so our guess is just going to be the exponential part. When we differentiate it, it will have 6x coming down to the front. We can see that that's 6 times too much, so we need to put a 6th in front of our guess and then add our constant. Second one, inside function is x squared, differentiate that is 2x, so here we've got a multiple of the derivative. So our guess is going to be sine of the x squared. When we differentiate that, we get cosine of x squared but multiplied by the derivative of x squared, so 2x. Look at how we can adjust the derivative to get the original function. Well, we're multiplying by 5 over 2 and do the same to our guess. So 5 over 2 times sine of x squared plus the constant. Next one, again, probably trickier type, these ones, but this is sine of x all to the power of 5 multiplied by the derivative of sine x. So our guess is just going to be sine to the power of 6 of x. Differentiate that and we get 6 lots of cosine x sine to the 5x, and then we look at how we need to adjust it, and again we need to divide by 6, so a sixth times our guess plus c. And that's it for this second video, and there will be a third one on a slightly different type, but hopefully that's given you an idea of how to do these ones. Okay, thanks.